Good morning, everyone. Thanks for joining our webinar today with Rothoblaas here on our webinar Wednesday. Today's topic is site water management. My name is Chris. I am the regional marketing coordinator for Rothoblaas here in the US and Canada. I just want to remind you, if you do have any questions throughout the presentation, you can send them into the Q&A section, which is accessible through your menu bar on a computer at the top of your screen, or if you're on a phone, you just have to hit the three dots in the bottom right-hand corner, and you'll be able to navigate your way over. So without further ado, I'm going to pass the mic on over to our presenter for today, Milvio.
Thank you so much, Chris. Good morning and good afternoon, everybody. My name is Milvio Sanchez. I am a technical consultant working here in the West Coast. I'm based in Vancouver. And in today's presentation, I'm going to go over site water management. But I would like to start with a statement that insurance costs 4 to 10 times higher in mass timber construction than other construction materials like concrete and steel. And those higher costs, those premium costs, are driven by concerns about fire and moisture damage during and after construction. So I'm sure you came here today because you know that this topic is relevant, and hopefully that throughout the presentation we're going to be able to address some of the challenges, the contests, research and development on this topic, and also some design recommendations that Rothoblaas recommends. For those of you who are not familiar with Rothoblaas, um, we are an international company. Our main headquarters is in northern Italy, in a city called Cortaccia, but we have 30 plus subsidiaries worldwide and 700 plus employees and 5 product lines covering more than 2,000 products. So essentially, we are supplying products and manufacturing fasteners, connectors, air tightness and waterproofing like sealant, tapes, membranes, soundproofing, resilient profiles, mats for walls, floors, for protection, tools and machines as well for the installers. So it's a full range for the construction architects and engineers in the mass timber sector. A little bit of our history. We started in 1990, pretty much side by side together with the mass timber construction. We and essentially our owner, Robert Blass, he started selling tools out of a van, and then the business developed so much that we started to introduce different lines, different ranges of products. So as you can see here in 2006-7, we introduced air tightness, fall protection, 2011 soundproofing, and now in the last trend here, pretty much every single year we are launching more and more innovative connectors for the mass timber. Our footprint worldwide is quite wide, so we are pretty much everywhere. We can supply from different warehouses from different countries, but essentially taking a look closer here to the North America, we have an operations in Pennsylvania, in Quebec, but we can supply products all over. In Canada, we have a big group, around 20 people. So we are all across the country. It's a big country. So depending on the province, you may find different sales rep, different field engineers, and so on. Same in the US, we have a big group from east to west. But regardless of your inquiry, we're going to be able to supply you with products. So going in more depth now in today's presentation. So I'm gonna go over 6 topics. So going from context and challenges, understand water risk on site, moisture and timber connections, which is a more structural topic, quality control on screws, design recommendations as well, and finally site water management best practices. So first things first. So in order to talk about site water management, it is really relevant to mention that we were building constructions and the job sites were looking like this. So not really large areas and small thin elements, let's say light wood framing construction and houses. So we were not building, let's say, massive projects. But now the reality, we are going bigger and bigger and also taller. So this means that now we are putting more stress, more stiffness into connections, and also we are dealing much more with hybrid construction. In this case, you have concrete shear walls, um, but there are several connections with steel to wood as well. So those connections are really relevant and different than those that we used to see. So as I said, we are going taller and taller, and the sky's the limit for the mass timber. Uh, every 5 years or so, when there is a code update, we are able to go higher and higher. And the connections usually were done in a simple way, like wood-to-wood connections with a single screw or with a bunch of screws. Now the connections are much more complex and they require several screws, different orientations for different purposes, and there is a presence of thick metal plates as well in conjunction with the wood. And the connections are and as well now are much more complex and dealing with much more different loading configuration and stiffness than before. So essentially we have larger projects um, which is going to take more time to get built. So it means more time on the job site. And if you have larger projects, larger areas, this means larger exposure to the weather as well. So more rain can happen on the job site. So this means more moisture. And as I showed you, so with this hybrid concept in mind and different connections having to deal with different stiffness and different connections, for example, a shear wall connected to CLT, which is a wood to concrete connection, we are talking about much more stresses and much more stiffness in the joints. So this is important to relevant and set the stage to understand the topic. Now we go to water risk on the job site. So water is inevitable in the job site. It's gonna rain. It rains everywhere. Um, but depending on the project, depending on the criticalities, and depending on the detail, it might be less or more critical. For example, here you see a project very nicely done where the CLT walls and CLT floors are all exposed, um, and tapes are applied in the CLT joints, as you see here, and then in the corners and the end grain of the walls. So this is a perfect ideal scenario where the corners, end grain, everything is protected, but still the side grain is unprotected. I'm gonna give you more examples and give you some research data, and then by the end you can let me know if this is ideal or not, or it depends. Now we have another example that only tapes between the CLT joints were applied, but all the end grain here of the CLT are exposed. So this is not an ideal condition. This is for sure way worse than the previous case. Other cases where you see there is even a step, very good for trapping water. It is raining on the job site, and there is only a single strip of Rothoblaas flexi-band trying to do a miracle over there. It's quite funny, but I'm gonna show you some results that taping or no taping actually helps a lot. Some other projects where not even they are not even constructed yet, but they are not fully built, but they are full of problems, as you see. Water pooling, and the CLT walls are already getting damaged, and decay is starting. It is evident here in this photo. There are other conditions where the installers and the GC are much more thorough on the design, or maybe this was specified by the architects as well, where temporary membranes, breathable membranes, were applied over the COT panels. But this case is also now not ideal. You see that water is forming on top of the membrane, so there is a water pooling, and essentially this has to be wiped out. This is not, let's say, suitable for those conditions. But still, you can see it's much more. That is a much more thorough process in terms of moisture mitigation here in this project. Other cases, really relevant cases, where you see project that has been closed with a moisture content higher than 16%. So in this case here, they closed the facades, but now there is a big problem that you have to rely on mechanical ventilation and really to dry out everything that is inside and with a higher moisture content. So pretty much there is a very intense climate happening over there inside the building. And you see stains on the wood, so for sure some architectural concerns, but not only that, there are some issues with structural components that I'm going to get there as well. So wood, as you may know, is a biodegradable material. It's also a combustible material and an isotropic and a hygroscopic material. So it means that there are some architectural risks when building with wood. Of course, there are many advantages. It's aesthetical pleasant. There is a sense of biophilia. People is gonna feel warm, feel nice inside those environments. But there is a risk that it may stain, it may get discolored, the timber can rot and decay, and the structural risk where swelling, shrinkage, and distortion of wood and finishes may occur, as you can see here in this connection. So it's evident that water can cause some problems, right? And talking about moisture content itself, so there is a sweet spot, which is 16%, where corrosion starts for fasteners. So anything below 16% is considered with zero corrosion. Anything above 16% corrosion starts to happen, and by 20% moisture content and above, it gets intensified, and it's going to be following not more a linear curve, but more like an exponential pattern here. And by 20% as well, we create the conditions, all of the conditions for fungi to develop and decay of timber as well to happen. So it's really important. So those were the thresholds as well, limiting and defining what is the dry service and the wet service condition. So anything below 19%, for example, is considered dry, and anything above is considered wet. But not only the moisture is relevant. So as you see here in this graph, on the center here, we have the map of North US and Canada, and either both the west coast and the east coast are raining a lot. As you can see, they are high or extreme. But the most important index for us in terms of construction is the moisture index, because you see that both west and east coast rains a lot, but the higher the moisture index, more problems for the construction will be. So you see here that the west coast here, for example, Vancouver Island, Portland, Seattle. So those areas, they have a severe moisture index, which means there is a higher humidity and moisture availability in the environment. And in these conditions, wood and the other materials, even if you place your clothes on a clothing line outside, is going to take much longer to dry because the air holds more moisture. And this, for sure, it's clear it's going to slow down the evaporation process because there is more resistance to the evaporation, as opposed to a low moisture index indicates a drier condition with lower humidity, where wood and any other material is going to dry much more quickly due to faster evaporation rates. So building a project in Vancouver, New York, Quebec, or Arizona is completely different in terms of those perspectives. We were used to build, as I said, with mass timber, stick frames, thin elements, um, but now there is a transition and mass timber is popular everywhere. But the main difference that you can see here that you can spotlight is, first of all, light frame construction are made it out of thin elements. They don't hold a very huge volume. They are they are repetitive. They are redundant. And light wood framing is getting wet faster because it's smaller, is thinner, but it's getting drier very fast as well. And it's also easy to repair, right? It's easy to spot and to see a leakage, and you just remove like the plaster board. You can see something going on inside, or maybe you already be able to see it, and then you fix the problem. Um, but mass timber gets soaked in a lot more moisture in a hidden way, and also as you see here by the size of the elements, it's a much more bigger component, much more big element that is going to hold much more moisture, but it's going to take, of course, much more time to get wet, and as a result, much more time to get dry as well. So those are the differences. So it's not really a timber issue, but more like a product specific concern or something that we have to keep in mind. I made a joke about the taping or no taping, but here in these results, there are some nice external research done out there that either a half-lap connection between CLT or a butt joint, no matter what, if they are left exposed, they gonna reach moisture content higher than 20%. One, either one is gonna be after 4 days and butt joint after 17 days, but they're gonna reach wet service condition in the field. But if you tape it, so as you see here, if you tape it, you maintain the moisture content of the panel below 20%, below 19%, and in this case, you have a dry service condition. So the tape may seem something something similar, something simple, but it helps a lot. So here you can see some photos of the results. If you tape the end grain as well, you mitigate a lot of moisture being traveled to the end grain, and it travels 100 times faster than the side grain. And also, tapes are important, as I mentioned on the graph. It is relevant, but it's not a really moisture-proof configuration. Tapes have to be considered, has to be only thought as a protection only against the short-term wetting, and it's not like an effective long-term exposure. There are other interesting research out there from RDH. So they had a wet CLT on a job site, and the concrete was about to be poured over the CLT, and they were thinking, should I let the CLT get dry, or is it fine to pour the concrete? The CLT is gonna dry out eventually. So this was a very interesting research that they investigated all the lamellas of the CLT, and they investigated the moisture content. So as you see here in the first condition, the surface and the bottom lamellas of the CLT hold different moisture contents. But pouring concrete in this configuration, pretty much after a year from June to June, they were able to get this panel dry. So now let's say we can call it a dry service condition for these panels. In a much more wetter configuration here, June to June, still pretty much all of the lamellas are, let's say, just the bottom one is under a wet service condition, but all the others remains in a wet service. And so this is a much more critical scenario. They also simulated one condition where they applied like one artificial rain, and you see it's even worse the results here. So it's really important to point out that the side grain of the CLT also matters. So as I said, it takes longer to get wet, but it also takes longer to get dry. Other researchers out there as well, really interesting recommendations that they mention that the CLT panels have to be either installed with a factory installed self-adhesive, either temporary or permanent membranes on the side grain, all the corners with a moisture resistant tape, end grain as well taped, and also liquid apply membranes could be used. So different conditions for different type of joints. Really interesting research out there. Regarding mass timber construction, the target or the threshold that we should be targeting is moisture content of 16% before enclosing the project. So this is a little bit different than lightwood framing construction, which should be, let's say, a 19. But with mass timber is really relevant to keep that number in mind. And also this APA guide here has some really relevant and interesting guidelines in terms of storing and handling of glulam beans, and also this works for CLT panels. Protecting from rain, of course, not leaving exposed to the ground, leaving some gaps for ventilation, protecting from the sun. So this may seem obvious, but it's nice to have it there on a specific guide. Now we are changing the topic. We are gonna hit a more like a structural topic, which is moisture in timber connections and the behavior of moisture. What can happen in a timber connection? What are the effects and consequences? So first of all, I would like to show this connection to you. So here we see many different problems. You can point out many different problems, but just by looking at it, you can see some wood decays is already starting, corrosion of the fasteners for sure. There is water present on the job site, and failure of the fasteners. It's not something that we were really, let's say, shocked to discover. And also in this case here, if you realize that if you pay attention, you're gonna notice that there are 3 different fasteners connecting steel to wood, where only one has been specified. So in this case, you see a countersunk head, flange head, and also the correct X head. And also they are a little bit misaligned, and we don't know the torque about these screws. So I could list 2 more issues in this connection, but let's keep these ones for now. So coming from that connection, that idea, Rothoblaas decided to invest in an experimental campaign. One of the experimental campaigns that we investigated moisture. There are many that I'm gonna quickly give you an overview about it. But this one pretty much was, the idea was to assess moisture content with thin 2 millimeters plate, with a thick 12 millimeters plate, and with a thick plate with xylophone, which is a resilient compressible acoustic profile. So in this case, we were able to measure the moisture exposure then in a wet condition. And after 6 weeks, this was the results that we observed. So pretty much the wood was expanding and swelling, and the thin plate was allowing that movement because it was not super stiff. As opposed to the thick plate configuration, the thick plate was much more stiffer, and it didn't allow any movement at all. And all of those stresses and all of those swelling forces goes directly to the screws and to the connection. And we also have an intermediate configuration with xylophone, which allows some sort of larger load distribution over a larger area. So why steel to timber connections are important? Because they are everywhere now with hybrid construction, and this configuration here is critical because as you may know, the longitudinal direction of the glulam beams and the timber itself doesn't swell, doesn't shrink that much. It's negligible. But cross-sectional wise, so the tangential and the radial direction, it is not negligible. And in this case as well, we are placing timber elements inside steel profiles where they are confined and constrained. So now if they want to swell, they can't swell. So they're going to be restrained with very stiff elements. So this is where issues may arise. So let's say here, looking by this animation, let's say if you have a facade with thick plate connecting steel to wood screw, and then if this get wet, so the timber is going to be a little bit drier in the interior and very wet on the exterior. So there will be a gradient of moisture, of transport moisture that's going to push this screw and create an unintended force on the top of the plate. And this is going to be absorbed by the screw. And this is something for sure that most of the times is not considered and not assessed during the design phase. So this is a critical unintended force due to swelling that may happen on the job site as well. Other research campaigns that we have done on this topic that we have completed, we assessed thick plate with CLT as well under high moisture content. We analyzed the swelling forces, thick metal plates, and hydrogen embrittlement as well, all of these effects. And at the University of Alberta as well, we analyzed the behavior of self-tapping screws under moisture content change in glue beams, placing load cells and evaluating how much force was being transferred due to swelling as well. One of the interesting results is if you install, for example, a VGS 9 by 200 under a standard 12 Newton meter, which is the recommended installation torque that we recommend for this screw. So 12 Newton meter, and if you install it in an over torque way, which is like a 60 Newton meter, you're gonna have different residual tensile force. So if you have 12 Newton meters, which is this case here, the standard and the correct installation, you are talking about a residual force on the screws below 2 kilonewtons, which is totally fine. But if you over torque these screws to a 60 Newton meters, you are talking about an average of 16 kilonewton, which is the green curve. And so this case here, there is a lot of force already there in the connection, just by over torquing. I'm not really talking about dead load, live loads, no load. So this is just a force, an extra unintended force due to torque. So there are two conditions that can give you some extra unintended forces. So over torquing is one of them, and swelling. So as I mentioned in the first few slides, we also supply tools. We manufacture, we develop, and one of the tools that we have is a torque limiter. Because I forgot to mention that in this case here, it was used a torque wrench to close the screw and to finish the installation. But we have a tool called torque limiter, and what it does is exactly what it says. It's a limiter of torque during the installation. So you pretty much couple this mechanical tool on any single screwdriver that are in the market, and what it's gonna do is, as soon as you pre-select the torque on the torque limiter that you want for depending on the diameter of the screw, depending on the length, and then as soon as it hits that torque, it's going to disengage, so the tool is going to not transfer more torque to the screw. So you can make sure that all of the connections are installed with the same torque, and it's a faster way than checking torque by torque in every single screw. Because as I said, this is relevant and can create some unintended tension forces. Other research that we have done, we assessed the swelling as well and different configurations with misalignment and acid timber in wet conditions, because depending on the wood species, it matters a lot. The corrosion may be more significant or less significant depending on the wood species. And ongoing now, we are doing some membrane behavior in the presence of damage, what happened there if water goes inside, and if you have breathable membrane, how much time is going to take for the moisture to escape the COT, and the difference between types of membranes. But the main conclusion, or one of the main takeaways from this research, was that for the shear connections for wood to wood or steel to wood, there is no much more increase in force due to swelling, as opposed to actual force, which you have here on the screen. So if you increase 6% the moisture content, to a variation of 6%, is going to increase the actual force, the design actual force, by 20%. So I put it in yellow because it's okay, it's a higher force, but this may be captured already by the resistance factor, conservatism, and redundancy on the design. But with steel to wood, there is a much more critical configuration with the same 6% moisture variation. The increase of force is much more higher and significant. That should not be neglected. Another interesting fact that we observe is that wood without any elements, any steel on top of it, is gonna freely swell and is gonna move without any blocking. And thin plate, as I said, it's not super stiff, is gonna also allow the movement of wood. And thick plate is the most critical problem, where wood cannot swell and all of those forces are transferred to the screws or to the connection in particular. We Rothoblaas, we have different proprietary coatings. So we have zinc coated, organic coated, C4, C5. So the main advantage of this coating is that it gives a very high corrosion resistance. So the corrosion resistance increases and the mechanical strength is kept the same. So it doesn't impact the mechanical strength of the screws. As opposed to installings, right? That you the bigger the corrosion resistance, the smaller or the lower the mechanical strength is. So that's one of the advantages of using coatings. We also have different range of products like hardwood screws, softwood screws that doesn't require a pre-drill if you are dealing with hardwood that has higher installation torque. We also have fully certified in the US and Canada and Europe VGS A4 and VGS A4, VGS and HBS plate. So the plate screw for steel to timber and fully threaded screws in A4, which is a very high corrosion resistant steel grade. And on top of the coatings that we have, we also provide a full range of stainless steel options. So going from high corrosion resistance, and you can use as well not really a high corrosion, like a less corrosion resistant screws. And this is the main chart here that depending on the project that you are building, the location, the timber that you are timber species that you have, and the moisture content, you may have to use different type of fasteners. One may not be suitable for that area and vice versa. Now I have a few slides about quality control. So as you see that aesthetically, wood can get compromised and can get damaged with moisture, it's clear, but also the structural components as well, they may suffer from some failures. So in this case here, we have a failed screw in a very critical condition where we are installing a thick plate with wood. The screw is under corrosion, there is presence of water, screw is already misaligned, and let's say this is over torqued. So premature failures may occur, which means a failure that is below the expected failure zone. And one of the conditions could be due to hydrogen embrittlement, which is fairly associated as well with moisture on the job site, pretty much the exposure to hydrogen. Also, it's a matter of how big your sustained load, your sustained tension is, and fastener hardness. So environmental hydrogen embrittlement means the one that happens outside on the job site. So the bigger the sustained load, the bigger the hardness, and the bigger the hydrogen exposure, that is a sweet spot that all of these three combined together may create brittle failures. So essentially, if you have never heard about hydrogen embrittlement, it is a permanent loss of the ductility of the metal caused by atomic hydrogen, in combination with load that can lead to a failure in a certain time. There are two types: environmental, that can happen with exposure to moisture, and internal hydrogen enrichment with exposure to hydrogen during the manufacturing plant. To control internal hydrogen enrichment, we have a very huge quality control practice in our facility, where we have a core hardness set to below 390. We have inhibitors in the pickling bath to suppress hydrogen generation. We do post-galvanized hydrogen enrichment baking on screws, and we manufacture according to the ISO 15330. In order to tackle the environmental hydrogen enrichment, we developed this guide, a smart book, and we are launching a new one very soon, where we give some trainings to the audience, like this one that we are giving. We give some installation trainings, installation support, technical support, and we also invest a lot on research and development in product innovations, waterproofing on membranes, proprietary coatings, torque limiters, and so on. The CSA 86 is the first standard worldwide to talk about specific hardness for screws in the market. So there you may find that case-hardened carbon steel self-tapping screws shall not be greater than 390 Vickers, and they have to satisfy requirements of the internal hydrogen enrichment test. So this is what Rothoblaas does. So we have screws below 390 Vickers in accordance to ISO, and we perform internal hydrogen enrichment tests on the screws as well. So this is really relevant, and we hope to see that on other standards worldwide. Today's topic is not about hydrogen enrichment, but if you are curious about it, if you want to hear more about it, visit our website or scan these QR codes. We have developed with the New Zealand Timber Society this timber screw technical bulletin. We have a white paper on our website, many blog contents, and hydrogen enrichment webinars presented in several sessions. The last slide that I have about perimeter failures is this one. So essentially, you can fail you can fail a connection in different cases. So first of all, by the installation, by the moment 0, you can fail a connection by overstress. So you can pretty much fail the screw while you are installing it. So this is completely on the installation side. Or if it not failed already, with an additional swelling component, that screw may be above the design capacity of the screw and may fail. And there are other conditions that perimeter failures can happen. I mean, building site type of failures. I'm not talking about service condition failures, like fatigue, accidental loads, catastrophic events, and so on. So one of them is internal hydrogen enrichment, which may occur within hours and days. And then in weeks to months, there is the environmental hydrogen enrichment, which has to be tackled, which has to be mitigated in a teamwork exercise between manufacturers, designers, and installers, because all of them play different roles in mitigating those type of failures. Now I have some design recommendations to give it to you. It's mainly more targeting structural engineers, but it is really interesting for the installers, architects as well in the audience. So first of all, the CSA 86 talks about dry service and wet service condition. As I mentioned before, the dry service is where the average equilibrium moisture content of wood is 15% or less on average, without exceeding 19%. So this is the maximum threshold. So anything above 19% is going to be dealt and considered as wet service condition. There are some footnotes as well in the code that says that wetting may cause wood swelling and generate high stress, as I presented before. And this problem is exacerbated when screws are used with steel side plates. So this is exactly one of the research campaigns that I presented to you. And also other codes around the world as well are touching on this topic. So the Eurocode 5, the 2025 execution draft, they have a moisture control plan session that a target equilibrium moisture content during fabrication, erection, and in service has to be in place, and any detrimental swelling and shrinkage has to be assessed and avoided, and also the wood itself, the timber, has to be protected against any moisture uptake. Not only about moisture plan, they have a really nice session about steel to timber connections, where they mention that the tightening torque of the screws should be defined by the manufacturer and should be respected and follow as the manufacturer specify. And most importantly, that the screws should not be overstressed. Now I have here a photo to highlight to you how, let's say, a connection lives in the real world, right? So first, we have always an environment that this connection is being exposed. We have the moisture content and the relative humidity that's going to play an important factor on the moisture content of the wood, the reducing or not reducing, or let's say maintaining the same capacity, that the maximum capacity that we can achieve, but also the screws or the steel cylinders, they always live in a timber, for example. So in this case, the environment that the connection is present, the moisture content, and the wood species or the environment the screw is installed, all of those three matters if we want to talk about durability. In our literature, you can find definitions of dry, wet conditions, whether you have an internal element exposed but covered, exposed not covered, and the different atmospheric corrosivity classes, which matters the moisture content, the distance from the sea, and the pollution. So it goes from a class C1 to C5, and also the wood corrosivity classes that is defined by the pH of the timber and the moisture content. So you may have different and more aggressive conditions. The higher the number, the more aggressive it is the condition. So now I have a little exercise for you. So let's say we are building this project in Denmark with spruce pine fir, which is not an acid wood. And we are close to the ocean, we are close to the industrial area as well, so it means a lot of pollutants. This area rains a lot. So if we are talking about designing the interior connections here, these connections for sure are in dry service condition. It's not raining inside the buildings. So this can be treated as a T1 class. So it's the least aggressive of all of the classes. And the ones that are exposed and not covered, for sure, this is going to be seeing a higher moisture content. So the same timber, same connection have to be designed or have to be specified as a T3 class in this case. And when we talk about the interior in terms of corrosion classes, atmospheric corrosion classes, in the interior it doesn't rain, pollution is controlled, there are humidifiers all around. We are talking about a C1, but outside we have for sure a C5, which is an area close to the ocean in an industrial zone, and it's raining a lot. So it means that in one single project, depending on the condition that you look, you may have different fastener that may be suitable for these configurations and different ratings or different unintended, different risks that may occur in different conditions here. And most importantly, I talk about wet service condition and dry service condition, but I didn't mention the temporary wet service condition. So if you have this photo here, you have a steel to wood connection, all the CLT walls and floors are exposed, no protection on the end grains at all. And of course, there will be a time that the roof is going to be placed and this building is going to be enclosed. But by the time the roofing is not placed, this connection or this system, this first floor for sure, or they have to be considered as a wet service condition, as a temporary wet service condition. This is important because the fastener, the connectors, everything that you choose has also to be able to deal with the wet service and the temporary wet service condition. For how long they will be temporary, right? Sometimes it's a week or two, sometimes it's 6 months, sometimes it's a year or two. And this is relevant, as I mentioned to you, in metal to wood connections. And if you have different stiffness or different rigidities, for example, if you have very high dense wood with no high dense wood, so it creates the similar behavior with metal to wood connections. Fastener inclination, we have investigated a few research campaigns as well in order to be able to tell something to the timber sector, because currently for wood screws there are no clear indication about what is acceptable. For the concrete world that is plus minus 6, but for timber screws, as you see here, if you can see a screw already crooked or misaligned, for sure you can tell this screw is misaligned by at least 10 degrees. And if you cannot see, you can still have a 5 degrees. But we put it in green because with 5 degrees, it seems to be correct. It's fine, this plus or minus 5. It doesn't impact the capacities at all. And this is where the installer should aim. But anything above 5, 10, 15 is not acceptable at all and has to be reinstalled. So let's say you are doing a site inspection. You look at this connection. You were about to say that this is a pass, but it's a steel to wood connection. As I said, it's a thick plate. But then if you look at it in a different angle, you may be seeing that all of these screws are actually not seated on the plate. They are misaligned by almost, I don't know, 30 or even more than 15 for sure. So for sure, the ideal configuration here is to replace these screws and install this again. So you see that the inclination sometimes is neglected, and this happens on the job site every single day. A few of the design best practice that we recommend is whenever possible or when risk is higher, to use damping system for absorption of the wood deformations. So preferring larger diameters and also short screws. This is going to be able to follow more the movement of the swelling and less unintended stress is going to be transferred. Spring washers as well, and prevent details that avoid let's say water being trapped, and distribute the load and across multiple short fasteners to prevent localized stress. And of course, install following the manufacturer's recommendation, using jigs, protecting the connection with tarps, membranes, tapes, and so on. During the design phase, currently the design load is always calculated in a way that it has to be lower than the tensile strength of the screw, so the resistance of the screw. But there are two components that cannot be neglected, or they have to be reduced as much as possible, which is the over torque and swelling. So those unintended tension has to be either included on the design or minimized as much as possible by correcting installation and by a moisture control plan in action, let's say. Not every single connection is critical, not every single connection is relevant. So that's why we developed this risk evaluation matrix, which pretty much talks about the design plan, the execution plan, and the fastener specification. And it gives ratings like scores, low, medium, and high. And you're gonna have, let's say, a risk score guideline. Low risk with minimum intervention required, medium risk, some target measures has to be implemented, and high risk exposure, some comprehensive mitigations has to be taken into consideration. So let's run a quick example. Let's say you are designing with wood to wood, and the design intent is that this project is going to be under a dry service condition. but you are not sure about the installation, and for sure during in a temporary condition, this is going to be under wet service condition. You are using a regular zinc coated screws, and the core hardness falls within the 360 and 390 Vickers. So this case, we have 3, 6, 10, 12. So you have a minimum, medium risk. So some, let's say, advanced coating, some temporary protection might be recommended. But by simply installing the screws in the correct way and following manufacturer recommendation and protecting the membrane, for protecting the CLT panels with membranes, temporary membranes, taping the end grains, you can reduce this wet surface to dry. So now in this case, if you do the sum again, you're gonna fall in a low risk condition. So you can play with this matrix and develop your own as well. This is just a suggestion, but this is interesting and important to say that not every single connection is on the high risk, and not every single connection demands the same level of moisture protection. Now the last and quick session here of the presentation, site water management. There are different guides out there. Guides prepared by FP Innovations, by BM Trada, or RDH. So all of these guides are really the state of the art in order to have a successful project. I just brought a few slides here from RDH, which is a very interesting guide that they they classify the different runoffs and also different connection cases, which ones are more critical, which ones has a low moisture exposure with a high moisture exposure, and also different detailings or different protection strategies that you have to think about it. So either like a taping or a fluid membranes or uh, protecting on the end grains on the corners, and also the nail laminated timber US design guide. They also talk about recommendations from isolated areas, protection only in isolated areas, going from the high protection level where all of the panels are wrapped up. But anyways, the contractor is the one responsible in the specifications to make sure that there is a moisture plan in action and it's being implemented. And also, usually it's written that moisture higher exceeding this amount, let's say, should be considered excessive and remediation should be taken by the contractor. And also moisture monitoring has to be done extensively to keep the moisture readings below 16%, and especially before enclosing the projects. And some field strategies that may happen, which is water deflection as much as possible, or temporary drains. So here in this photo here on the right lower corner is a project that Rothoblaas was involved. It was really interesting to see that the customer protected the whole building site with a grid of membranes. So pretty much no dust, air, snow was able to get inside the project. It was really interesting. And also they spoke with the structural engineer. They drill a hole like right here. They kind of made temporary drainage because the upper level was open to the weather, and also they installed like a steel roller just to guide the moisture a little bit and to place the moisture away of the job site. It is not perfect as you see, but it gives you some ideas, or it shows how thorough they were in the design and also in the construction phase. As I said, moisture monitoring is really relevant. Mass timber may look perfect from the outside, but sometimes from the inside it may be really wet, and then mechanical ventilations, wiping out other solution has to be considered. And lastly, tenting, right? So of course it depends on the budget. It's not really something that we see in every single project, but there are some examples in North America and Europe as well, that even some movable tents are used, where as soon as they finish the first floor, the tent moves up, and you can make sure that every single floor is protected as it is protected to for rain and from any exposure to weather. So here you can see some photos of successful projects, very interesting ones, where tenting has been used. And lastly, the connection details, right? So very little changes on the direction, very little curvatures or not, let's say, sharp edges can allow moisture to not get trapped, and your connections is going to not suffer from this moisture absorption. It's clear that the end grain is much more critical than the side grain, but it doesn't mean that the side grain it is not um, negligible, right, in terms of moisture. So ideally, the condition here to protect this panel, this configuration, is taping the end grain, panel protections, temporary or permanent, over the CLTs, and splashing and water protection where needed as well. So Rothoblaas has some options, which is options that are on the budget. They are permeable or robust. It's like life. You can never get time, money, and energy. You have to choose two. But we have several solutions, either structural solutions, temporary membranes, tapes, or even um, structural shear metal plates that instead of having moisture being trapped in plywood, spline joints, for example, um, you have just a clear um, metal plate that doesn't trap moisture, or aluminum profiles that raise the CLTs above the ground, tapes and membranes as well. Other invisible tapes, if in structural inspection is really like a must, you can really see through. And ideally, all of these membranes and has to be installed in the factory first, and then the panels are already protected when they arrive there. So finally, so moisture control should be part of the design execution, right? Design and execution, not only as a site issue, and prolonged wetting combined with restrained connections or overstress of the fasteners can lead to swelling, corrosion, and premature failures. Moisture monitor has to be taken during the construction and before enclosing the structure, and avoid the details that trap water, protect vulnerable interfaces, use drainage, tapes, membranes, and choose screws, membranes, any product that is suitable for the design intent, and that they are being follow the correct installation procedures by the suppliers. And lastly, designers, suppliers, and installers has to work together, and this requires teamwork in order to reduce moisture-related risk. Thank you so much for your attention, for being here today with us, and hopefully that you can join our next webinars. And if you have any questions, I'm more than happy to answer them. Thank you.
Thanks, Milvio. I'm looking here. One question was asked if this session was being recorded. It will be made available in the future on YouTube. So you'll be able to see it there in the near future. And a question here for you. It's going to be asking you how these issues should be addressed in your opinion. It says strapping the CLT joints was proposed as a good solution to keep the joint dry. In my experience, in many cases, this leads to water trap below the membrane and extremely wet and damaged plywood splices. Also, membrane on the top of CLT floors need to deal with site reality. People constantly working on the membrane, damages, MEPF penetrations, column to column connections, etc. Once the water goes below the membranes, it becomes extremely difficult to remove it. So,
Mm-hmm.
in your
Very
opinion, how do you
interesting.
think that those should be addressed?
Mm-hmm. No, that's very interesting point. Um, yeah, for the membranes, so that's why it's really important. The ones that we produce and the ones that we supply is called defense adhesive transpire. So it means that this membrane is breathable. So even though there are, let's say, a little damages or there are a little, let's say, even if the membrane gets wear off by, let's say, people walking on top of the membrane, or there are some scissor lift that maybe tear apart the membrane. We never know what happens on top of the membrane. So this membrane will allow moisture to to go up and to dry the CLT panels. So this is like an extra safety factor. So the membrane is there to be waterproofed, but then if there is any moisture that goes underneath the CLT, by all means, this moisture is allowed to dry. And regarding the connections, I guess there was a question here. Yeah, so ideally, so let's say in this case we don't see membranes, but if you place a membrane on it and then if you hit with a screws, ideally you should tape it on top of the plates as well, just to make sure that this is fully protected. So yeah, so spline joints and plywood joints are really critical, and as I said, they can swell a lot and they fail in a very catastrophic way. Thank you so much, Chris. Yeah.
Yep. I'm just seeing for this next question, I just see people are asking about the certificate of completion for this presentation or continuing education credits. We'll send an email out to those who are in attendance to this presentation that meet the guidelines for the continuing education credits that we're able to provide. With that, I just want to thank everybody for joining. As always, if you have any questions, feel free to reach out to eng.na@rothoblaas.com. We do have future webinars. The next one's coming up in 2 weeks on June 17th, and it's Advancing Timber Engineering with the Rothoblaas Fastener Design Guide. So with that, enjoy the rest of your Wednesday and the rest of your week.